And there's a few different types of logarithmic problems we're going to look at to specifically start us out today. Tomorrow we're going to look at, today we're going to specifically look at growth. Tomorrow we're going to look at using logarithms with decay. Today we're going to look at using logarithms with exponential growth. Tomorrow we're going to use logarithms with exponential decay. And then on Thursday we're going to have a quiz, and then on Friday we don't have school. So yeah, how it is. Yeah, it's just how it is. So for today's assignment.
No, we have one Thursday and Friday.
Friday the 31st?
Oh, yeah, Friday in Shepherd.
Friday what?
In Shepherd.
Shepherd, yeah.
We have the game here, then by 12:30 we go to Shepherd.
Who do you guys play tomorrow?
Okay, quiet please.
What's over?
I thought it was next Friday, because how the 31st comes so fast?
Well, today's the 17th. Yeah.
I thought it was
Today's
the 31st.
Today's the 17th.
Are you sure, Rebecca? I thought we were sitting on the 31st.
That's for our first game that we missed against Shepherd.
Oh, we played twice.
We play every time.
Yeah, but we play Shepherd here. Is this gonna be the second time you guys play?
It's okay. It's okay. It's okay. It's okay. It's okay. It's okay.
Oh,
All right. So for today, we're going to be using two equations. I do not have these equations included on your paper, so you have to make sure that you have these written down somewhere, and don't just write them down and then crumple up the paper and throw it somewhere. I'm not. You know who. And I'm not going to give you guys these equations again. So make sure that you have these equations somewhere. So for population growth.
Oh yeah.
So you're going to need those two equations for today's assignment. So make sure that you have them written down. One is for population growth, the other is for consumer loans. We've covered both of them in the recent past, so you might already still have both of them in your notes, but even if you do, I'd still like you to write them down again. So what we're going to do today is we're going to be using logarithms to solve for time. So what we've covered before is we found out with population growth, like how many people there will be after a certain amount of time. And what we're going to do today is flip it and find out how long it will take for a population to reach a certain point. Also, we found out consumer loans. We found out how much the consumer loan would be worth. Today we're going to find out how long it'll take for you to pay down your loan to a certain amount, assuming that you're paying the minimum payment. Okay, good. So in order to solve for time though, because time is up here in the exponent, we need to, yeah. Okay, so let us start with population growth. So let's say that India, well actually let's not do India, let's do something smaller. No, America's on your assignment.
Saudi Arabia.
Okay, sure, we can do Saudi Arabia.
You terrorist?
Well, I don't want to do China because the population's too big, and I don't want to do huge numbers.
Saudi Arabia is by Ethiopia, and half like Ethiopia's population is like 12 in dead, so this makes it easier on us.
So, okay, so currently the population of Saudi Arabia. Okay, quiet. So the population of Saudi Arabia as of today is 28.83 million.
It's a lot.
Okay, quiet.
Our population is like 4 billion.
America is on the assignment. That's why I'm not doing it. I said that. Jeez. Okay. So, between these 2 years, let's see, 28.83, and then the one before, 28.29, 28.83 minus 28.29. All right, so it's growing by 1.9% per year. So, for a problem that's going to be similar to what's on your assignment, Saudi Arabia, because Gus requested it, has a population. I don't know why I split that word up like that. Of about 28.83 million. Just be quiet back there, people. And grows at 1.9% per year. What we want to know is how long will it take to be 35 million people?
I just spelled low.
Okay, then don't. I'm sorry. All right. So in order to do this, we're going to need to use the population equation that we have in your notes right now. So the population equation, which is right above this, is that the starting amount, or the amount is equal to the starting amount times 1 plus rate to the years. Now in this case, we have the amount that we want it to be, which is 35 million. We have the starting amount, which is 28.83 million. We have the rate that it's growing by. We just don't have the years. So the years is what we're going to be solving for, and this is where the logarithm comes in. So setting this up, I'm just going to say 35 million is the amount that we want it to be. 28.83, and I'm not writing the whole millions thing here because I don't want to have a ton of zeros on my paper. Times, in parentheses, 1 plus. Now I have to write 1 point. Yeah, I have to write 1. Yeah, 1.9% as a decimal is 0.019. And then I'm raising it to the power of years, so I'll just call that x. And I have to be able to solve for x. So this is why we did what we did yesterday. So I'm going to do a couple things to simplify this. 1 plus 0.019 is just 1.019 to the x power. And then this is times 28.83 equal to 35. Now I have to get 28.83 onto the other side. If it's being right, I have to divide both sides by that number. Awesome. No, this is great. Super glad you guys are paying attention.
1.21.
So 28.8, so 35 divided by 28.83. I'm going to round that to 2 decimal places. So 1.21 is equal to 1.019 to the x power. Now, at this point, this is an equation where you have a constant that's equal to a number to an exponent. Part of your assignment will have you doing that. having you take it from the equation that you have in your notes and having you break it down to a constant equal to a number to an exponent. So that's a big part of your assignment, is having you get this far. Now we need to use a logarithm to rewrite it. So it would be log, and what would the base of the log be?
1.019.
Right. So 1.019 of 1.21 would be equal to x. Now on your calculator, you'd evaluate that by doing, so no, it would be log of the bigger number divided by log of the little number. I know you do. Not everybody does. So you do log 1.21 divided by log 1.019, and whatever you get from that would be equal to x. That's rounding to 2 decimal places. Now, this is a word problem, so we have to have units on it. What's the units on that? No. Years.
Million years.
So in approximately 10 years, Saudi Arabia will have 35 million people. Okay? All right. Let's take a look at your assignment now.
No, it's in the logarithms.
There is more ones. We're going to do... Don't worry, the next chapter is simpler.
I'm just tired.
I know.
So Steve,
I think we should just switch on to this class. That semester.
what are we gonna get into?
I'll sign your sheet.
What will we do?
I don't know.
Gable,
pretty sure I don't-
Gable wants us to get the sports man.
Already done that.
I will sign any sheet that gets put in front of me for people transferring up.
Of this semester,
Yes.
this week.
You wanna
Yeah.
talk to Michelle?
Yep.
I'm not gonna get into it.
Okay, so for this assignment, okay. So taking a look here, Billings, Montana has population growth of about 1.8% per year. Population as of 2013 was 109,059.
That's in Billings?
Mhm.
I feel like it's way more than that.
Well, these are the last accurate numbers we have was 2013.
When do they do that? Like, how often do they?
4 years.
So every 10 years, there's an actual accurate census, and Google makes an estimate every 4 years based on the census. So, but there's an actual accurate census every 10 years, and that's part of the Constitution. Okay, so write an equation to model the situation. This would be based on population equation.
Yeah, but do you want us to put in like the amount?
Yeah. So the amount we don't know.
Skip the C.
Right. The amount we don't know. So, actually, yeah. So I guess I should have put the 200,000 in there.
Yeah.
So, 200,000. So we want to figure out how long it's going to take for Billings to get to 200,000 people. So we want to write an equation to model the situation. So we're going to put 200,000 over here, equal to 109,059 times 1 plus 0.018 to the x power. So this would be your answer to A. Solving it down to a constant and an exponent, a constant equal to a number to an exponent, you would do 200,000 divided by 109,059. 2 decimal places, that would be 1.83 equal to 0.1 x power.
And then the littlest one goes first, right? Isn't that what you said?
So it's when I say little, when you rewrite this as a log, what would it look like as a logarithm?
Log 1.018.
1.018. So I call this is the little one. So it's not the little like size of the number. It's this one, and then this is 1.83 equal to x. So when you're evaluating it, it would be log of 1.83. So this number goes first. So I guess you could think of it as the second goes first and the first goes second, if you want to think of it that way. Divided by log 1.018. And then whatever you get out, round it to decimal places. And so,
About 33 years.
okay.
34 years.
How do you get 1.83?
So I got 200. I got that by doing 200,000 divided by 109,059.
Or do you get 100,000?
200,000 came from part C. That's what we're trying to get it up equal to.
I
I
What
should.
do you get the 100,000?
109,000. That came from the. That's what Billings' population is as of 2016.
What did you get? Did you get 33.87? Harley?
What?
You got 33.87?
Yes.
Okay. So Brett, right now, or not right now, in 2013, the population of Billings was 109,059 people,
Yeah.
approximately. We want Billings. We want to figure out how long it's going to take for Billings to equal to 200,000 people.
Okay.
So setting up that equation for part A, the amount we want is 200,000. Billings is starting at 109,059. It's 1 plus the rate it's growing. You have to change 1.8% to a decimal, 0.018, to the x power.
So it's going to take 33 years for it to reach 200.
Mhm.
That's a long time.
Mhm. Yeah, I could do the numbers.
That's steady rate.
Yeah, if it keeps that steady rate. If it doesn't increase or decrease in its rate of growth.
Wait, how do you
So if you evaluate this, log of 1.83 divided by log of 1.018.
wait divide by one?
Because this 1.83 comes from doing 200.
Well, yeah, I got that, but why would you divide 1.83 by 1?
So it's log of 1.83 divided by log of 1.018.
Yeah.
Because it's, when you're rewriting it, this is the base of the exponent, so it's the base of the log. And then this is what the exponent is equal to, so it's what goes here. And then when you're rewriting it as evaluating the log, just like when we, so like on the warm-up, when we had 3 to the x plus 2 equal to 100, it was log base 3 of 100 equal to x plus 2. Evaluating that, it was log 100 divided by log 3. Kind of sort of, Rebecca?
Yeah, I just mixed up the,
You got the numbers
yeah,
flip-flop?
I
Me
divided,
and Anna don't even try to do chairs anymore.
1.018 divided by 1,000.
That happens. Okay, one thing that I think is interesting, I don't know if you guys have ever looked into this.
For you, that's easy to say. $4,000.
No. So the population of Roundup, I don't know if you guys have ever looked at this.
2,800, is that right?
It's
Did it
1,859.
go down?
It went down. It went down a lot.
What it's been almost constant for the last 20 years. Like the population of Roundup is almost flat if you look at it over the last 20 years.
That's adding me to the list now, too.
What's the highest and lowest it was ever at? since then?
So in the last 20 years, the highest was in 1996, 2,142, and the lowest was in 2010, 1,801.
And with you.
That was right before I moved to.
Oh,
Right after I moved.
So, right, but that's not that big of a change. Roundup has been flat almost for the last 20 years.
What was 2006?
2006, 1,896. Almost no difference from now.
That was 3 years before I moved.
Okay.
I moved here in 2009.
So in 2009, approximately 1,966.
I had 4 people in
So I think Roundup is kind of interesting just because Roundup has been almost entirely flat.
Yeah.
But we have such a transient population, like people move in and people move out.
Because of the coal mines.
Right, but they move in and move out to a point where like they almost always replace each other. Almost as many people move in as people move out. I think it's interesting.